Hello. So I've noticed several other speakers at this conference mentioning that they have PhDs in physics. So I guess I should confess that I have one of those too, in case somebody's keeping statistics on how big the invasion is. I'm going to be talking to you today about some experiments I did where I challenged audiences at various conferences to come up with keyword searches that would perform better than supervised machine learning. I'll drop a little secret, go early. The audience lost every time. So in order for you to understand why we did things the way we did, I need to give you a little background on my industry, which is e-discovery. When there's a lawsuit, one of the parties in the suit can go to the judge and request through this process called discovery that the other side have to turn over certain types of documents to them so that they can look for evidence that bolsters their case. Once documents started becoming electronic, people tacked an E in the beginning of it to call it e-discovery. During the e-discovery process, if a large corporation is sued, they might have to dig through millions of emails and other documents to look for anything that is responsive to one of these discovery requests. Typically, a lawyer will review all the documents that are going to be produced to the other side in advance to make sure that they're truly responsive to the discovery request and to potentially redact things that should not be disclosed. So having a lawyer review a document like this is going to typically cost you between $1 and $8 per document. So if you've got 10 million emails, you really don't want to have a lawyer review all of them. So various technologies have been used over the years, like keyword search and supervised machine learning more recently, to try to cull down that data set. And then the lawyers are going to review that culled down data set before they're produced. So if the other side feels like you didn't turn over something you should have, and they can prove that to a judge, your side could get sanctioned by the court. So reaching high recall is very important. So recall is really the quality estimate of the result. On the other hand, since we are going to have lawyers review the documents before they're produced, we also want high precision. We don't want to waste lawyers' time at $1 to $8 per document reviewing a lot of documents that were not relevant that we could have potentially avoided. Another thing to keep in mind is that prevalence is potentially very low in this kind of case, this kind of situation. Could be less than 1% of the documents are actually relevant to the case. Keyword search has been used for many decades in e-discovery, despite the fact that most of the evidence says it doesn't work very well. So in 1985, Blair and Marin did an experiment where they took two lawyers and they asked them, what recall do you think you need to reach for it to be an acceptable production? And they agreed 75% was a reasonable number. They then gave those two lawyers 40 different topics that they needed to search for documents on. They also gave each lawyer a paralegal who was trained in this fancy new thing called a search engine. And it's kind of funny to read the paper and have them describe what a search engine is, because nobody knew back then. What they found was in the 40 tasks they were given, they managed to hit 75% recall one time. They managed to get higher than 50% 3 times out of 40, and on average, they only got 20% recall. Now, they were allowed to examine the results of their keyword search and tweak the searches, but there are some criticisms that they didn't go further than that. For example, they didn't do sampling from the documents that didn't match the search to see what relevant documents they had missed and get some ideas to tweak the query based on that. So people have been saying for years, well, you know, that's 1985, we're better now. So the Text Retrieval Conference had a section called the legal track that went on for several years, where there were a bunch of e-discovery experiments done. And in an article put out in 2009, where the guy who ran that thing was interviewed, he said that in their experiments, Boolean keyword search found between 22 and 57% of the relevant documents. So a bit better than 1985, but still pretty far short of that 75% that people say is reasonable. So despite that, people have been using keyword search for many decades, and it's actually been kind of an uphill battle to get the e-discovery world to move into things like supervised machine learning. Lawyers are not early adapters of things. And they have this problem that if they go and they use some new technology and then they go to the court, the other side challenges it, that the judge might say, hey, you're using something unproven, we're going to sanction you for not doing a good enough job. But finally, around 7 years ago, judges came out and started saying in public it's okay to do this stuff. It's gotten some traction in the industry. Now, of course, the rest of the world refers to it as supervised machine learning, but the legal world never uses the same words as anybody else. They have to come up with new names. So it is alternatively called predictive coding or technology-assisted review, or TAR for short. So you may hear me use those words. If you get into the definitions of them, there are some subtle differences, and there's lots of disagreement about how to even define these words. But for the sake of today's talk, you can just treat them all as being supervised machine learning. So how do we do a fair comparison between something like keyword search versus supervised machine learning? If one approach gets higher recall but requires more of that expensive document review from those expensive lawyers, is that a better result or a worse result? It's too ambiguous. So we want to make sure that we can do a comparison that's really fair. So one option is to fix the level of recall, meaning we require a certain quality of result and measuring the amount of effort that it takes to get to that level with different approaches. A different approach is to say, I'm going to put a fixed amount of effort into the review process. What's the highest recall I can get by using these different approaches? Either way you do this, you do want to make sure that at least some of the systems that you're testing are hitting a level of recall that would actually be acceptable in court. It really does, running a comparison where keyword search hits 5% recall and supervised machine learning hits 5% recall, which one took the least effort really doesn't tell you anything that's relevant for the real world, because you'd probably get in trouble with the court if you actually used either approach. So as I mentioned at the beginning, I went around to 6 different e-discovery conferences and challenged the audience to produce keyword searches that worked better than technology-assisted review or supervised machine learning. The data set that was used was 100,000 magazine articles. It's really hard to get real e-discovery data because it would be some corporation's internal documents that they would not want to release to the public. So about the only data set that's available is Enron. But we also want them to be fully categorized, meaning some human being decided whether or not each individual document goes into a particular category. It was very carefully done. So that way we can instantly measure what recall was achieved with various systems and do experiments. So I did this at 6 different conferences. The process actually varied a bit from one conference to another as I tried to tweak it to make it better. So in the early stages, I had audiences working collaboratively and writing out keyword searches on paper, and I would type them in and evaluate them, and really didn't give much opportunity for the audience to revise their queries because the whole process was too slow. But in the last iteration of this experiment, we actually had the audience in a room full of computers, 42 participants, each with their own computer. They would go to a web page, type in their keyword search, click a button, instantly find out what recall they achieved, and they would see a list of the top 100 documents, whether or not each one was relevant, and then some extracted keywords for each document so they could very quickly revise their search queries and try to make them better. They had a choice of 3 different topics they could work on: biology articles, articles about law, and articles about the medical industry. They executed a total of 1,924 queries. We gave them 20 minutes to work on this, and we graphed the recall they hit as a function of time, and it definitely plateaued well before 20 minutes, so they really weren't improving much beyond that point. Although some people continued to go as I was talking afterwards and cranked out another 20 minutes or so. So it's an average of 45.8 queries per person. So they got lots of shots, lots of bites at the apple here, and lots of opportunities to try to do better. And I should point out that we sort of gave the audience an unfair advantage because when in the real world, if you constructed a keyword search and then you ran it, well, to evaluate the results, you'd have to have some human reviewing individual documents to determine whether or not they're relevant. So that has a cost. But we gave them that for free in this example. So we gave them instant feedback for free, and they still couldn't tweak things enough to beat the machine. So this is an example of some of the data. So this is the biology topic. We had more people do biology than anything else, probably because it was the first item in the drop-down menu. So I want you to focus on the bunch of bars on the left. So there what we did was we said, we're going to have people do their keyword searches. Now, if you just do keyword search in the normal way, you're going to select a set of documents, and that's going to have some associated recall and precision. but we want to compare things that are sort of equal. So what we said was, we'll take the top 3,000 documents from their keyword search, and that's going to be the set that we're going to evaluate. So keep in mind, the keyword search engine is going to tend to put the best documents that match the query best toward the top. So we're basically taking their best 3,000 documents. And if their search gave less than 3,000 documents, we gave them a little warning saying you're probably not doing as well as you could. So we took the top 3,000, said everybody's doing equal effort, 3,000 documents worth of review if the humans actually had to do the work of reviewing them. For the TAR system, the supervised learning system, we actually have two bars here, so light blue and dark blue towards the right-hand side of that set. Light blue, we had the system trained with 200 documents, and then once you train the system, which is the support vector machine, once you train it, it sorts the documents based on relevance score, so that documents that have the highest probability of being relevant are at the top, and then you sort down. So we took the top 2,800 from that set and combined that with the 200 training documents and measured our recall. So we are including the training effort in the process here, so we're not giving that for free to the TAR system. Each vertical bar here represents the best effort from a single human reviewer. So if a person executed 40 different queries and query number 25 gave the highest recall, that was the one we graphed here. So this is the best effort from all of those people. And what you see is that the best effort from the best person is still below those blue bars. Oh, and I forgot to explain the second blue bar. The darker blue bar, we again trained with 200 documents. The training is using a method we call TAR 3.0, which is something I talked about at this conference last year. So you should have been here last year. Sorted the documents by relevance score, had the system review the top 100 documents, and then allow the SVM to learn from that and make better predictions for the next 100, and it keeps learning throughout the process. So just to show you, when you compare those two bars, it shows you how much a difference it makes to allow the system to continue to learn. So the left side was the top 3,000 documents, and I said, well, what would change if we allowed the keyword search people to take a bigger set of documents, say 6,000 instead of 3,000, so double the effort? That's the set of bars on the right, and the colors correspond. So what you see is when we increase the number of documents, yes, their recall gets higher, but TAR still beats them. The interesting thing is to compare the blue bars on the left set to the rest of the bars in the right set. And what you see is that most of the time, human beings doing keyword search, even with twice as much review effort, they rarely beat what TAR can do, or supervised machine learning. So this is the medical industry topic. It was not quite as popular, so there are fewer people here. But again, same sort of trend as before. Supervised machine learning very easily beat the humans. This is the legal category. You would think more people would be popular as biology. But again, same sort of trend. Supervised machine learning won across the board. I should also mention that the participants here were people attending an e-discovery conference. They're not necessarily search experts, but you would think there were probably at least a few people in the room who are probably doing this stuff for a living in the e-discovery world. So why did the SVM do so much better than human beings? So this is a linear support vector machine that was doing the supervised machine learning. So we can actually extract out a keyword search that's equivalent to the SVM result. And we can take a look at it here and try to understand what it was doing. By the way, I should also mention that all these slides are up on the website in the presentation section. So first of all, our keyword search, the terms are weighted, and it's all purely an OR search. There's no ands and no nots in here. So it's really aimed at sorting the documents based on using the right weights. We have positive weights here shown in blue, negative weights shown in red. And the important thing to note is the ... here. Okay, there's tons and tons of terms that are not on the screen because I only had so much space. So you have hundreds of words with positive weights, and we had thousands of words with negative weights. So first of all, having tons of words with positive weights means that we can hit high recall pretty well. I mean, we're not going to miss very much if we've got so many of those terms in there. If we had a much smaller set of positive terms constructed by a human, there'd be a better chance that we would miss some document where they just didn't think of the right words to use. Another point is that these weights are very carefully tuned by the system to fit what actually works optimally on the data, as opposed to a human being trying to guess which words are important. Also, the SVM takes into account correlations between words. So that's something that would be really hard for a human being to take into account. And notice some of the things that happen here. For example, biotechnology has a weight of 774, whereas biotech, which is really the same thing, has a weight of 448. So things that you probably could not guess in advance, but it measures what actually works. Another thing to notice is that the highest weighted word is the word scientists, which sounds like it would be too generic, right? It's going to bring in documents about chemistry and physics and other stuff. But if you look into this big list of words, and you can't see them all here, words like physics and chemistry have negative weights. So you'll often see magazine articles that say something like scientists discovered, and then some very specific thing, which might not match your keywords, but the fact that the word scientist is in there still allows it to be discovered when we're aiming for really high recall. And here are the references. I know it's hard to read those guys because they're links. So if you do go to the website, you'll be able to click those links and get to the articles.